Good, good morning, respected guest. I am Siddhi Raghuvanshi of class 4th A. Good morning, respected guest. I am Siddhi Raghuvanshi of class 4th, and these are my team members. And our project name is the Floating Hotel of Burj Al Arab.
My name is Manav Garg. I am going to tell you about world's tallest hotel made on man-made island. Burj Al Arab is one of the lakes of luxurious in the world. The shape of this structure is designed to resemble a sail of a ship. It has a helipad near the roof at a height of 689 feet above the ground. The Burj Al Arab was designed by architect Tom Wright.
Construction team faced many challenges that never took place in the history of engineering. Challenge number 1 was to impress Dubai's rulers Mohammed bin Rashid, and it was done by British architect Tom Wright. He presented a design of sailing boat and it was approved by the ruler. Now, the challenge number 2 was to build this hotel on an artificial island. After 5 months, island was ready, but they all are afraid with ocean currents and tsunamis. They hit the island, they will move round and round.
Now the challenge number 3 was to build a solid foundation for the hotel. To secure the foundation, the builders drove 230-meter long concrete piles into the sand by drilling method. The building contains over 70,000 meter cube of concrete and 9,000 tons of skeletal structural frames of Burj Al Arab. It is the only 7-star hotel in the world and it is made by Zumeria Group.
That's all about our project. I hope you like our project. Thank you.
Ashvi Mangal from grade 10, and these are my teammates. The name of our project is The Making of Engineering Giant Burj Khalifa, described as both a vertical city and living wonder. Burj Khalifa, developed by Dubai-based Emaar Properties, is the tallest building of this world. Our project is divided into 5 stages, and each stage will be explained by my teammates. They will tell you about the problems faced by the engineers and how they overcome those problems and the mathematics used.
I, Advika Agrawal from grade 9th, is going to explain you the phase 1 of the Burj Khalifa. So the Burj Khalifa is the tallest man-made feature on this planet and one of the greatest achievements in engineering history. This is the story of one incredible skyscraper and the people risking their lives to build it. With a total built-up area of 5.67 million square feet, the Burj Khalifa is the tallest architectural giant. This $1.5 billion tower opened in 2010 with the best firework display ever seen. But this patch of land once was very different. 6 years earlier, when construction started, it was little more than a barren land and sun-baked desert. So now other phases will be explained by my other teammates. So now you may proceed.
From class 9, this is the phase 2, the base construction. The architecture feature a triple-lobed footprint, an abstraction of 6-petaled desert flower called a Malocaris spider lily. The tower is composed of 3 elements arranged around a central core. The modular Y-shaped structure provides us inherently stable configuration, and also it provides attractive floor plates for the residential area. Thank you.
My name is Manogya Jain and I am from grade 6B.
and I'm going to they faced during the making of Burj Khalifa. The first challenge they faced during the making was that are the foundations strong enough to keep the building upright. Earlier on the analyzation of the ground, they found that they're having a top settled layer of sand which performs to get them weak limestones, weak sandstones, nothing good for a good foundation for such a high skyscraper. Now you may move to phase 3.
Sashi from class 10 and I am going to explain you the phase 3 rectified area. As you know, the challenges was regarding the strength of foundation, but the science provides the answer. The future of Burj Khalifa and its colossal weight rests on the simple principle friction. Out of two methods of piling, they used skin friction, in which the weight was carried on the friction of piles under each side of the pile. Now, the further explanation will be done by Ayansh.
Good afternoon, respected chief guest. I am Ayash and I am going to explain you the rest of the part of the phase 3, that is reactive area. So, beneath the tower, the team has to drive in 192 pipes in the depth of 50 meters to support a 3.7 meters thick rod of solid concrete. These foundations must hold up a building that weighs over 5 lakh tons, but the numbers were so big, so the team has to allow a single degree settling in the design. Thank you. You may proceed.
Good afternoon, respected guests. I am Kushi Rajput from class 10th.
I am Kavya Pundir from class 8th.
I'm Yash from class 9 and today we are going to explain the phase 4 construction site of Burj Khalifa.
Excavation for Burj Khalifa started in year 2004 in January. The building had to achieve its goal to become the tallest man-made structure, and in order to achieve its goal, it had to pass through many milestones. So, 45,000 cubic meters of concrete was used to create the foundation of this building, which piles up to 192 piles, that is buried under 50 meters or 164 feet deep.
Burj Khalifa employs a record of breaking 330 cubic meters of concrete, 39,000 tons of steel, 103,000 square meters of glasses, 15,500 square meters of embossed steel, and the tower took over 22 million man-hours to build. In November 2007, the highest reinforced concrete core walls were pulled up at a vertical height of 601 meters using MP80 concrete, and the pressure while pulling up the concrete was nearly 200 bars.
Now the question arises, how did they lift the concrete to this height? Due to the warm weather of Dubai, even if they had used the most powerful pump, the liquid concrete would have solidified before reaching its destination. Instead, the team has used a special grade concrete named C50 and C80. They mix the cold ice in it and pull it up. This work of pouring the concrete into the mold base done at night and immediately said. The team has completed one floor every week and the entire project took 6 years to complete it. Thank you.
So here is the final structure of the global icon, the Burj Khalifa, which is 828 meters in the height and having 163 floors in it. The main soul of the Burj Khalifa is its hexagonal core. This RCC built core is an ultimate hero, enabling the source of the Burj Khalifa to keep standing it over here. Thank you.
Good morning, ma'am. My name is Yashmi and I am from class 6A. But such as the slender core is highly unstable and could fall at any time. But Skidmore, the company that designed Burj Khalifa, come up with an innovative solution. They took inspiration from the buttresses we usually see it on the dams to hold the core of the walls. It used the similar support around the core. Thank you. The next explanation is explained by my senior Parth.
Good morning, ma'am. Good morning, sir. My name is Paul Parekh from class 9th. So now we have to understand. So now we have to understand the notorious property of concrete. This is the weakness of tensile stress. When a concrete block bends, tensile stress is caused in that section of the block. Concrete was only withstand with a small amount of tensile stress. For solving this problem, we have used steel rods in the hexagonal core of this structure. So we have used a I-shaped structure also, which make this structure comfort and able to stand with tensile stress. Thank you, and next further will be continued by Yogita.
Good morning, my name is Yogita and I am from grade 6, and today I am going to tell you about Burj Khalifa. The interesting thing is that 70% of the Burj Khalifa is supported by concrete core. The top 25% doesn't have any support of concrete core. It is a steel structure. Burj Khalifa has an asymmetrical structure instead of symmetrical. This is because of vortex shading. Now, what is vortex shading? Vortex shading is an oscillating flow that takes place when air flows to a body at certain velocities. In this flow, the vortices are created at the back of the body and detach periodically from either side of the body. To overcome this issue, Bill Baker and his team come up with an architectural innovation. Their idea to break vortex shading was to create spiral in the Burj Khalifa. The spiral shape is the best solution to kill vortex shading, as it just confuses the wind as the shape varies. Can you find a hidden spiral in the building structure? You can see the spiral very clearly. If you have observed Burj Khalifa, you can see it also have been structured with the same technique, towers varying heights forming a discrete structure. Now the further explanation will be explained by Vedant.
From grade 7, I am explaining you the windows of Burj Khalifa. And the tallest building of the world is covered by glasses. But in Dubai, it was a special challenge for the team because of the temperature. But our team used the high-tech solution and make some glasses which have two coatings. First coating was of silver, which reflects the UV rays, and second was of titanium, which reflects the infrared rays. By reflecting UV and infrared rays, the heat produced by sun is reduced, and when it penetrates, it reduces. Thank you and have a nice day.